2.3, the second derivative. So to understand the second derivative, first of all, let's start from the basic. If you have y, you do differentiation, then you will get dy over dx. This is called first derivative. If you do differentiation for the second time, then you write as d2y over dx squared. So this is second derivative. Okay, that means you have to do differentiation for 2 times. But if let's say if you have fx, then when you do differentiation, you will have f prime of x. If you do differentiation again, then you will get f double prime of x. So the idea is 2 times of differentiation. Okay, so we see the notes here. Differentiate the first derivative. That means differentiate this. Then you will get the second derivative. So the second derivative is equal to the differentiation of the first derivative. D over dx means differentiation of the first derivative. Or f double prime x is equal to the differentiation of the first derivative. Okay, so let's see one example. It is not hard one. As long as you remember the formula of differentiation, this one will just work accordingly. So you have y equal to 2x cubed plus 4x squared. You differentiate, you will get 6x squared. Then you differentiate 4x squared, you will get 8x. So now when you want to differentiate again, so we call it d2y over dx2. Okay, so then when you differentiate again, 6x squared become, imagine the power 2 move in front and multiply with 6, so you get 12x. The x squared you minus 1, then you get x power 1. So that is the idea of differentiation. Then differentiate 8x, you will get 8. So this is the second derivative. So which seems like nothing special. It's just doing it for 2 times only. Okay, f prime of x. So this x is missing. So our question is 5 over x. It is not suitable to look at this for differentiation. So that's why we bring up the x, 5x to the power of -1. And now we can start doing the differentiation. Okay, so the power -1 move in front, become minus 5x, and the power -1 just now, you minus 1 again, it becomes -2. Then we have minus 5 over x squared. So like that. Okay. Sometimes we need to use chain rule and do it for 2 times. Okay, so this is the example. And so on. Okay, now let's look at the next page. 2.4. Application of differentiations. So we learn so many formula to do differentiation, and at the end of the day, maybe you're wondering why we want to learn differentiation. Okay, so this is the reason. The first reason, we learn differentiation so that we can find out the gradient of the tangent and the gradient of normal. Okay, how to find? Okay, let's imagine. Okay, I give you a simple example here. Let's say I just use this. I use this as my example. I draw out the graph so that you can see what is tangent, what is normal, and how differentiation is involved. Okay, I draw out this graph first. Of course, graph sketching of this is not compulsory here. The question never want us to sketch the graph, I sketch the graph so that you can see and you can illustrate on it. Okay, so let's see. I write the equation first. So I want to sketch the graph. I factorize x squared, x minus 2. I factorize so that I can find out the x-intercept. So now I want to find the x-intercept. I let y equal to 0. Then I get 0 equal to x squared, x minus 2. And then I get x squared equal to 0, x equal to 0. I get x minus 2 equal to 0, x equal to 2. So I have two x-intercepts. And I know this is power 3 graph. Power 3 graph, I know the graph is going to be like this or like this. Okay, so it is like this if you have y equal to ax cubed plus bx squared plus cx plus d, where your a is more than 0. Your graph will be like this if you have y equal to ax cubed plus, no need, if your a is less than 0. Same equation. Okay, same equation, but a is less than 0. And then it's like this. Basically, if a is more than 0, right, it is going up at the end. Okay, going up at the end, which means here, going up at the end. If a is less than 0, it is going down at the end. So for our case, the a is the number in front of x power 3, which is 1. Our a is 1. Okay, I write it down first. Since our a is equal to 1, which is more than 0, so our graph is going to be like this. Okay, let's say I sketch the graph. I know when the root is repeating here, x squared equal to 0 means x is equal to 0 and again x is equal to 0. X is equal to 0 for 2 times. I know that when the root is repeating, the graph is going to be like touch 0 and then go. We call it touch and go. Okay, so touch and go at 0 because it's repeating root. And then this 2 is not repeating, it's just one root only. 2 is a single root. So then the graph will cross. Let's say the 2 is somewhere over there, and then they will cross. But the graph sketching is not important now, of course. I sketch it just for you to see how its tangent looks like. Okay, now you are given with a point 3, 9, somewhere here, 3, 9. They ask you to find the gradient of the tangent. So what is tangent? Let's take a look. Tangent is a straight line that passes through the given point, and at the same time it touches the curve at that point only. And that's the tangent. Okay, so again, this is tangent. And what is tangent? Tangent is a straight line that passes through a particular given point. So the point is given as this 3, 9. So tangent at this point, of course, it passes through this point, and at the same time it touches the curve at that point only. And other than this point, it never touches the curve anymore. So this is tangent. Okay, and then what is normal? Then normal is another straight line which is perpendicular to tangent. So this green line is normal. Okay, now the thing is, it is a straight line. No matter it's tangent or normal, it is a straight line. So we can use straight lines formula. Y minus y1 equal to m, x minus x1. Or you can use y equal to m, x plus c. So you can use any two of the straight line formula to find the equation of tangent. And likewise, normal is also a straight line. So to find the equation of normal, you can also use y minus y1 equal to gradient x minus x1, or y equal to mx plus c. Okay, any of the formula. So the difference between tangent and normal is the gradient. As you can see, the tangent, the gradient is like this. The normal, the gradient is like that, where they are perpendicular to each other. So let's say I make it looks different. Gradient of tangent, I use mt. Gradient of normal, I use mn. So there is a relationship between the gradient of tangent and gradient of normal. The relationship is gradient of tangent times gradient of normal is equal to -1. This is the perpendicular formula. So when you multiply them, you will get -1 because they are perpendicular to each other. Okay, so let's come back to our question here. Our question said you have to find gradient of tangent. That means you have to find gradient of tangent, which is mt. You have to find gradient of normal also, which is mn. So how to find gradient of tangent and gradient of normal? So you can see here in the notes. Gradient of tangent, they call it m1, m2. I call it mt and mn. Okay, it doesn't really matter. Okay, so to find the gradient of tangent, we have to find it in this way. Value of the first derivative at the point constant. So that means you want to find gradient of tangent, right? Maybe you look at this sentence, you feel like don't know what they're talking about. So you need to do two things. I need to do two things. The first thing is differentiate the curve. Second thing, substitute the x coordinate given into dy dx. So two steps. Differentiate the curve is to get dy dx, basically, to get dy dx. Once you get dy dx, then you substitute the x coordinate given into the dy dx, and then you will get gradient of tangent. Then you get gradient of tangent. Okay, then let's see example. Okay, I already draw the graph for your illustration. Okay, so actually what to do is you just need to follow the steps here. Differentiate the curve. This is the curve. Y equal to x cubed minus 2x squared. That is the curve. And you can see the curve over there as well. So we just need to differentiate the curve. dy over dx. 3x squared minus 4x. Now we differentiate already. Then second step, substitute the x coordinate. This is the x coordinate. Substitute the x coordinate into x, here and here. So when you substitute, you will get 3 squared minus 4 3, which is 27 minus 12, which is 15. So this 15 is gradient of, I have no space to write that long because I still need to find gradient of normal. So I just call it gradient of tangent equal to 15, mt. Now you want to find gradient of normal, you have to use this formula. Gradient of tangent times gradient of normal equal to -1 because they are perpendicular. So this is the perpendicular formula. So if you rearrange this formula, right, then you get m2 equal to negative 1 over m1. So you put the gradient of tangent at the bottom, and then with a negative in front, then you get the gradient of normal. So gradient of normal equal to negative 1 over gradient of tangent. Now I want to get gradient of normal. Negative 1 over gradient of tangent, negative 1 over 15. So that is gradient of normal. Okay, so you can see in general there are 3 steps to do this. First, differentiate. Second, substitute the x coordinate, then you get the gradient of tangent. The third step is use the perpendicular formula to find the gradient of normal. Okay, so these are the 3 steps. Okay, let's move on. Okay, so you already know how to find gradient of tangent and gradient of normal. Now they ask you to determine the equation of the tangent and normal to each curve at the given point. So you need to use straight line formula. You put the gradient of tangent that you obtain over here, and then the x1 and y1 is basically the given point. For example, this point. So you put the point inside here and here, then you will get the equation of tangent. So equation of normal will be the same. You find out the gradient of normal first, something like this. Then you put it here. Then the x1 and y1 will be this point again. You substitute here and here, then you simplify it, then you get the gradient of normal. Okay, so there are more steps to do. First step, differentiation. Second step, substitute x coordinate to get the gradient of tangent. Then third step, use equation of straight line to get the equation of tangent. So if you want to find equation of normal, then you have to do the fourth step, find the gradient of normal. Then the fifth step, substitute the point inside. Okay, so I write down the steps again so that you are very clear on this. So y equal to fx, this is the curve. So you need to do differentiation, dy dx. Then you have to substitute x1, y1. Substitute x1, y1. Basically, we just put x1 inside. dy over dx equal to f prime. Substitute x1 into your x. And this is equal to gradient of tangent. And then you use y minus y1 equal to gradient of tangent, x minus x1, and then you get equation of tangent. Then you use gradient of tangent, gradient of normal equal to -1, or gradient of normal equal to -1 over gradient of tangent. Then you will get gradient of normal. Then you use y minus y1 equal to gradient of normal, x minus x1, and then you will get equation of normal. Quite many steps to do here. Yeah, let's see one example. Okay, we look at the note first. So you can see it here. The tangent and normal are straight lines. The equation of a straight line with gradient m that passing through a point x1, y1 is this formula. Okay, so they tell us also, but it's just that they don't give more details like what I gave here. Steps. Okay, let's practice. So we have to do so many steps to find out the equation of tangent and normal. Okay, so let's start. First step, dy dx. Okay, let's do it. dy dx equal to 4x minus 5. Okay, second step, substitute the x coordinate into dy dx. Then you get gradient of tangent. Our x coordinate is this, which is 3. Substitute inside, x equal to 3. dy dx equal to 4, 3 minus 5. So which is equal to 7. Okay. I give you one more information which is quite important. Before you substitute the x coordinate into the dy dx, right? The 4x minus 5 here, there is a particular name. It is called gradient function. So gradient function, I write here. Before you substitute x coordinate, this is called gradient function, which means the formula to find gradient. So after you substitute, we don't call it gradient function, we call it gradient of normal. So that means this is gradient function, this is gradient of tangent, not gradient of normal, gradient of tangent. After you substitute x coordinate, we call it gradient of tangent. So I just write it down here, gradient of tangent. So the next steps, as you can see, we need to use the straight line formula to find the equation of tangent. Okay, so equation of tangent, y minus y1. So which is your y1 and x1? So basically it is the given point, this point. So x1, y1. So we substitute y minus y1 equal to gradient of tangent x minus x1. x1 is 3. Y minus 3 equal to 7x minus 21. Y equal to 7x minus 18. So this is equation of tangent. Okay, now equation of normal. So you see the next steps. We have to use perpendicular formula to find the mn, the gradient of normal. So gradient of tangent, gradient of normal equal to -1. Gradient of tangent is 7. So move the 7 to the other side. -1 over 7 is the gradient of normal. Okay, then you can see the next steps. Once you get gradient of normal, then you substitute the information, the same point and the gradient of normal, then you get the equation of normal. Okay, so y minus, our x1 and y1 are 3, 3. So y minus 3 equal to gradient of normal x minus 3. Minus 1 over 7x plus, okay, I use calculator straight away. 3 over 7 plus 3, 24 over 7. So this is equation of normal. Okay, so that is the idea. So from here, we already get the important information. Our first application of differentiation, we use differentiation to find the gradient of tangent. Okay, then after that you can find equation of tangent and equation of normal. Okay, so let's see a little bit more. Okay, now let's look at part C. Solve each of the following problems. Problem solving. So sometimes we have to do it in the opposite way, where equation of tangent is given, you see here. This is a tangent to the curve. This is the curve. Okay, so find k. So it seems like opposite already. But you remember, we have, okay, I try to draw out to let you imagine. We have a curve, so which is like this. This is y equal to 2x squared minus 5. Then I also have a tangent at one unknown point. I don't know where is it. I just simply put. So let's say it's there. Then your tangent is like this, passing through that point. So your tangent is y equal to 4x plus k. So I draw out the graph so that you can imagine. Okay, so it's something like this. So if you follow the steps, if you follow the steps, right, you want to find equation of tangent. First, you have to differentiate the curve. Not differentiating the tangent, differentiate the curve to get dy dx. So after that, you have to substitute the x coordinate into dy dx to find the gradient of tangent. But the problem is, we don't know the point here. We don't know x1 is what value, y1 is what value. We don't know about that. So what to do now is, okay, let's take a look. We want to find the value of k. Okay, we want to find the value of k. The value of k is here. Okay, is this value. Okay, so we don't know this point. That's the problem. We don't know this point. The only thing that we know is the two equations. If we follow the normal steps that I show you just now, it is going to be like this. Okay, you differentiate the curve. Y, okay, let's see. If I follow the normal step, y equal to 2x squared minus 5, the curve. Then I differentiate the curve, dy dx equal to 4x. Equal to 4x. Then after that, I don't know the x. Okay, I don't know the x, but never mind, I just do it. I already set here. I don't know the x, I call it x1. So now I substitute x1 inside here. Okay, so substitute x equal to x1, and then dy dx equal to 4x1, which is gradient of tangent. You know, just now I also mentioned y equal to gradient of tangent x plus c is the formula for the equation of tangent. So because of that, this 4, right, is the gradient of tangent. So when I use this information, that means my 4x1 is actually equal to 4, the gradient of tangent. So now you have to think it in the opposite way already, So it's actually equal to 4. So your x1 is hence equal to 1. We solve the equation. 4x1 equal to 4, then you bring the 4 over and divide. 4 over 4 is 1. So this is 1. Okay, so if you know that this is 1, then we can easily find the y1, where end up with, we know this. We know the answer in B first. Okay, so no matter how, we just continue first. if I substitute my x1 into this point, right, it seems like I cannot find the y1 because I have an unknown here. But if I substitute here, it is okay. If I substitute 1 here, then I can easily find the y. Substitute into the curve or equation of tangent will be just fine because this point passes through the curve as well as the tangent. So substitute into either one will be okay already. So I substitute into this. Substitute x1 equal to 1 into y equal to 2x squared minus 5. Then I will get y1. y1 equal to 2 squared minus 5. y1 equal to minus 3. So I get 1 minus 3 then, which is the answer of B. This is answer of B. They ask you to find the point of contact. Okay, then let's say now I want to find K then. So how am I going to find K? So since I have the point 1 minus 3, and 1 minus 3 lies on the tangent as well, so I can substitute 1 here, minus 3 here, then I can get K. So to find K, I substitute 1 minus 3 into y equal to 4x plus k. Because this point is at the same time on the tangent. Okay? The point is on the curve, is on the tangent as well. So that's why we can substitute the point into both equations. So I substitute. Then I get k equal to minus 7. So which is the answer of part A. Okay, so you just need to use the same steps like just now, and you need to know the gradient of tangent from the equation here, and then you can handle everything already. Okay, so let's see what we have on the next page first. So we have more questions.